Welcome back to another exciting chemistry lesson. In this lesson, we are going to learn how to write electron configuration. Now, this is an example of electron configuration, but this is also an example of electron configuration as well. This is the complete version, and this is the noble gas version. Well, the electron configuration tells us about the energies and the position of electrons in an atom, and it's always follow this format. When we describe an electron, we are describing three things. First, we're looking at the energy level, followed by the sublevel, okay? And then in that sublevel, what is the location of that electron is going to be? Well, in this case, to be exact, how many electrons are in that specific sublevel, in that specific energy level? Now, before we go over a specific thing, if you notice right here, we have S, P, D, and F. From here to here, right? From here to here, we have a total of how many boxes? 1, 2. So for the S, what we have here is 2 electrons per energy level. And notice how we have 1, 2, 3, 4, 5, all the way to 7. The period, okay? The period represents the energy level for P and S. If you notice how we have 1S, and then we have 1S over here, 2S, 2P, and so on. And then for the D is 1 less than the period. So here we have 4, now we have 3. Here we have 5, here we have 4. For the F, it is 2 less than the period. So in this case, we have 6. Right here we have 4, 7, we have 5. So with that information, now we figure out the energy level using the periodic table. We also figured out what sublevel the electron are located based on the location on the periodic table. All the S are right here, okay? All the P are over here, all the D is right here, all the F is right there. So by looking at the periodic table, it tells us right away. Now, one most important thing we have to remember that is energy level. The higher the energy level, if you notice, as we go down, the energy level increase. That means the farther away it is the electron going to be from its nucleus. So what does that tell you? Well, based on the Coulomb law, the further the distance, what does that tell you in terms of attraction? Well, you have less attraction between the proton and electron, and therefore it requires less energy to remove that electron. So that's tying back to the Coulomb law. Now, going back here, we also have something called orbitals. So basically, these are type of sublevels, okay? This is a sublevel. But sublevel contain orbitals, and the orbitals are represented by boxes. Notice how many orbitals do we have for S? Well, in this case, look at S, we just only have 1. So the orbitals are represented by boxes. Well, in this case, we have 1 box. But for the D, how many orientation does it have? If you look at this, they are the same shape, right? Well, it is the same shape, but they have different orientation. And now it has 3 different orientation. This gives us 3 different type of location for electron to occupy. Well, more specifically, 3 orbitals. Okay, so 3 boxes. And then for the D, how many do we see? You have to realize that each type of sublevel has different shape, and your job is to recognize those shapes. But most importantly, how many orbitals do you see? Well, 1, 2, 3, 4, 5. And sometimes they write it like this, okay? 1, 2, 3, 4. So they put it together, okay? And in this case, for the P, sometimes you will see them write like this as well. So keep that in mind. Now, lastly, we have what's it called? The F. The F has 7 boxes. 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, 6, 7. So the F has 7 orbitals, okay? Or 7 boxes. Now, based on the orbitals and the periodic table, you know right away that 1 orbital can hold how many electrons? 1, 2. So basically what's happening is the electron go up, the other one electron go down. Because the electron are negative, they would repel each other. So one go down, the other one go up. They have opposite spin. And this is going to be happening throughout all different type of sublevel. So now that we have a better understanding of how to use the periodic table to relate to the number of orbitals, as well as the number of electrons in the orbitals, let's write an electron configuration for it. There are 2 formats. The first one is the complete configuration. That means we start from the very beginning, which is hydrogen. The other one is the noble gas configuration. So instead of starting from the very beginning, we're starting from the previous noble gas. Hence, we have the name noble gas configuration. So let's see if we can write an electron configuration, how easy it is, okay? But before we write our electron configuration, there's one important principle that we need to follow, and that is the Aufbau principle, basically saying that electrons are placed in the increasing energy level first. So what is that really telling us? Well, remember the energy level here? When we write it, when we get to the D, notice how it's one less, right? So we have to write the D before the S. And then for the F, we have to write before the D and then before the S. So always remember, put the lower energy level first. So let's see how this is in action, okay? Are we ready? Let's do this. For the first one, write a complete ground state electron configuration for oxygen. So what we have here is we have oxygen. Where is oxygen? Oxygen is right here. And right away, how many electrons does oxygen has? It has a total of 8 electrons. So that's where we are going to stop, at that number 8 right there. So we start from the very beginning. We have, what is this? What energy level is this? Well, 1, right? Remember the format. Energy level, sub-level, and then the number of electron. So we have energy level 1 right there, and followed by the sub-level S, because this is right here. How many electrons in this sub-level S? 1, 2. Why do I keep going? Because remember, they are all the way, remember oxygen is all the way down here. So instead of writing 1s1 and 1s2 separately, that's too much work. So we just group them together. So now 1s2. That means there are 2 electrons in S sublevel at energy level 1. Now we move on to the next one. So in this case, we're going to energy level 2. See, we have to rewrite again because now we are in a different energy level. It has to be specific energy level, okay? So we have 2s what? Well, 1, 2. So again, we don't want to write them separately. We want to group them together. Less writing, less work for us, okay? And then followed by, what do we have? P. Remember the S and the P have the same energy level based on the period number? Look at that. So we have what? 2P. Well, 2P1, 2P2, 2P3, and 2P4. We don't want to write them separately because they're in the same sublevel, in the same energy level. So we have 2P4. And that is all we have to do. Isn't that nice? Now let's look at this. How can we write this in terms of an ions? Remember, this is ground state, okay? It's not the excited state. It's the lowest energy level state, okay? Now let's look at writing electron configuration for ions. In this case, we have -2. Well, that -2 tell you that we are gaining 2 electrons, okay, from oxygen. Well, oxygen originally has 8. What's 8 plus 2 equal to 10? So where is the 10 electron? It is right here, okay? So instead of stopping at oxygen at 8, now we stop at 10. And that's all we have to do when it comes to ions. Figure out how many lost, how many gain, and determine where we stop. So now we are writing, a noble gas configuration. So again, noble gas configuration start from the previous noble gas. Here's neon. What's the previous noble gas? Helium. So go back 1 energy level. So in this case, we start from helium. So we put in a bracket He, and after helium, what do we have? Well, we have 2s. Okay, so we have 2s. How many? 2. 1, 2. And followed by what? 2p. Okay, 2p. And keep going all the way till we get to the number 10, okay? Because we need a total of 10 electron. 1, 2, 3, 4, 5, 6. So 2p6, and that's all we have to do. Are you ready to do another challenging question where the energy level is a little bit off? Let's go to the D sublevel. In this case, write the noble gas electron configuration for zinc. We don't want to write a complete electron configuration anymore. It's too much work. So let's go back over here and start with our previous noble gas. In this case, right here, zinc. So the previous noble gas is going back, and that is argon, okay? So we're going to stop right there. So in this case, we put argon in the bracket, okay? And after argon, what do we have? We have 4s2, okay? We have 4s2, but keep it in mind, we have to keep the lower energy level first, and then we have 3d what? 3d10, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we are not going to keep that way. We have to write 3d10 10 first and 4s2. So the first thing you want to do when it asks you to write electron configuration, label your energy level first, okay? And that's all we have to do. Now let's write a configuration for a positively charged ion. In this case, we have aluminum 3 plus. Well, what's that tell you? The 3 plus is lost 3 electron. Well, in this case, aluminum has originally 13, right? What's 13 minus 3? Whoa, that's 10. Okay, so 13 minus 3 give you 10, which is right here. Again, neon. If you want to, you just copy the same thing as right here, which is the same thing. But let me show you again. So neon, previous noble gas, it is helium, okay? And then after helium, what do we have? We have 2s2, and followed by what? 2p6. There you go. Isn't that easy? Are you ready to go down here all the way to the bottom of your periodic table? Let's write an electron configuration for uranium. Uranium is all the way down here, okay? And we're not going to write the complete configuration because that is way too much work. Let's write the shorthand configuration or the noble gas. Well, in this case, uranium is right here. What is the previous noble gas? It is, radon right there, okay? See how we go back, right? Right here. So in this case, we put Rn in the bracket. After Rn, what do we have? So we have, what's this, 7s, keep going, 7s2, right? Followed by what? 6d1, and followed by, what is this? 5f3. 1, 2, 3. Okay, 1, 2, 3. Okay, but look at this. This is not in the correct order, right? Based on the alpha principle, we have to rewrite it. So in this case, the best answer is, or the correct answer is 5f3, 6d1, 7s2. And this is the correct one. This is the incorrect one. And that is how you use the alpha principle and the information from the periodic table to write your electron configuration. And you don't have to memorize any other pattern, okay? Because everything is given to you. Now let's go check our answer. Notice we use the caret symbol to indicate superscript because we don't want to waste our time doing superscript and subscript. That's too much work. So we just use the caret symbols, right, to indicate the superscript. So I wrote this in terms of, look at this one here, 1s superscript, 2s superscript 2, 2p superscript 4. You see how that works? And now let's check our answer, okay? So again, the format's a little bit tricky, so take the time to write it, and then we submit it. And there you go. That's how you write electron configuration, just using your periodic table and memorize specific information that allow you to understand the structure of an atom. Okay? So, and as always, if you have any question, show your work on a piece of paper, take notes, put it in the forum, and put your question there, and we will help you from there. And we'll see you next time on another exciting chemistry lesson.